Hey class, I'm doing a PowerPoint on atomic theory and I hope you enjoy. Alright, Atomic Theory by Chandler Hansen. What is atomic theory? Atomic theory is a theory of nature and matter, and it explains that everything is made up of tiny particles that we call atoms. What is an atom? Well, an atom is the smallest particle of an element. Most all of the atom is empty space, and at the center of the atom is a tiny nucleus composed of nucleons. We call nucleons protons and neutrons, and over 99.9% of the atom's mass is in the nucleus. Pretty interesting. What is an electron? An electron is a negatively charged particle. What is a proton? A proton is a positively charged particle. What is a neutron? Neutrons are tiny particles in the atom that have a neutral charge. If an atom has equal numbers of electrons and protons, then the charges cancel each other out and the atom will have a neutral charge. This was discovered by James Chadwick in 1932, as you can see there. The beginning of atomic theory. The idea of atoms had first been proposed by Democritus. He believed that everything was made up of tiny particles called atoms, and that they couldn't be broken up. But people in that day just weren't really having that, so 2,000 years later, Dalton came into play. In the 1800s, the English chemist Dalton did a number of experiments that eventually led to the acceptance of atoms. He carried out countless chemical reactions and published a book in 1808 called A New System of Chemical Philosophy. We know this is Dalton's law. Dalton's law consists of all matter is made up of atoms. Atoms are indivisible and indestructible. All atoms of a given element are identical in mass and properties. Compounds are formed by a combination of two or more different kinds of atoms, and a chemical reaction is a rearrangement of atoms. Thomson, in 1897, the work of English chemist J.J. Thomson, provided the first hint that atoms were made up of even smaller particles, and that atoms are divisible, so Dalton was wrong. He stated that atoms are made up of positively and negatively charged particles. He thought that positive and negative particles are spread out in the atoms like plums in pudding, but not exactly. They are positively and negatively charged particles inside atoms. Another important figure was Rutherford. In 1808, Rutherford discovered the nucleus. He stated that atoms have a small, dense, positively charged center called the nucleus, and is also known for the gold foil experiment. The gold foil experiment is way different than the plum pudding model. The particles bounced off of the gold foil, showing that the mass of an atom was concentrated in one region, but most of the particles continued through the foil, and that showed that the atom is mostly empty space. Here is a diagram showing the gold foil experiment, showing that when the particles bounce off, the nucleus is positively charged as a particle, and then when they go through, you can see that it's made up of mainly empty space. What is an element? An element is a substance that consists of atoms with the same number of protons. Elements are the simplest substances known. They can be metals, meaning iron, copper, and sodium, magnesium, or non-metals, carbon, hydrogen, nitrogen, and so on. The periodic table is a helpful guide, and the atomic number is a huge helping to understanding the element. Here is the periodic table of elements. There are three phases of matter: solid, liquid, and gas. Solid holds its shape, has a fixed volume, and the particles vibrate, as you can see there. Liquid is the shape of the container and has a fixed volume, and the particles slide past each other, such as that one. And gas holds its shape of a container, is the volume of the container, and particles collide against one another and are spread out. This is my video of the phases of matter. I'm just going to show you what happens
Alrighty,
when
class, we're going to do a video on
we
the
put
three
them in
things.
there.
I have here a hot pan and some salt. A solid holds its shape, as you can see here, has a fixed volume, and the particles vibrate, but do not move around. Here is a microscope for this pan. It's going to become a liquid. Liquid holds the shape of its container, has a fixed volume past each other. Here is a microscopic view of the liquid. And as you also saw there, you saw some steam. Steam is
Modern day atomic theory. We still go off of Dalton's atomic theory, except for a few of his concepts back then. We go off of all matter consists of tiny particles called atoms. All atoms of a given element are different than those of other elements, and atoms of one element combine with other elements to create compounds. They always combine equally. Matter being made up of little particles that are indivisible most of the time. Exceptions include plasma such as fire, other ionic arrangements, and those found in the body of radioactive materials. The wave-particle duality of matter. The wave-particle duality of matter turned out to be the key to the atomic theory. Physics had assumed that particles are particles and waves are waves, but it actually, de Broglie, or I can't pronounce his name, mentioned that particles could sometimes behave as waves, and waves could sometimes behave as particles. This is known as the wave-particle duality of nature. It seemed that matter exhibited both wave and particle properties depending on the situation. Huge objects exhibit very small wavelengths, so small we can't really observe them. Small objects, the wavelength can be observable and significant. Colliding particles will bounce off each other, but colliding waves will pass through one another and emerge unchanged, which you'd think that it would make a bigger wave, which that doesn't happen. Overlapping waves can interfere, but it's rare. A particle, if we flick the marble with our finger, we give energy to it, and the marble will continue moving, taking the energy with it. A wave spreads out. Waves are constant rollers on the open ocean, or small ripples in a pond. When you throw a rock, you can see the ripples in the water. There's also sound waves, which we cannot see, but sound definitely travels. And the major significance of wave and particle duality is that the behavior of light and matter can be explained through the use of an equation which represents wave function. Here's a quote. These probability equations can diffract, interfere, and exhibit other wave-like properties, resulting in a final probabilistic wave function, and that exhibits these properties as well. Particles end up being distributed according to probability laws, and therefore exhibit wave-like properties. In other words, the probability of a particle being in any location is a wave, but the actual physical appearance of that particle isn't there. And this is a video which I realize that I don't really have time for. Also, fun facts, did you know that almost all of the atoms have neutrons except for hydrogen, which is the tiniest atom? Hydrogen consists of 1 electron and 1 proton. Electrons move around outside the nucleus. J.J. Thomson in 1856 to 1940 created the plum pudding model, which consisted of plums are negatively charged electrons and puddings in the mass of a positively charged. The mass of a proton is essentially the same in that of a neutron. The mass of a proton is 1,840 times greater than the mass of an electron. Atoms cannot be divided using chemicals. They do consist of parts which include protons, neutrons, and electrons, but an atom is a basic chemical building block of matter. Water is the only substance that can exist naturally in 3 states of matter. And thank goodness for atomic theory. This has been a huge part of our understanding of Earth and the things on Earth. I'm so glad that scientists were willing to think outside the box and share these wild ideas, even though people thought they were crazy. I think without it, we wouldn't be able to explain a lot of things, and we wouldn't have as much of an understanding. The progression we have made may never have happened, and we should be truly grateful for these people in our past. And these are my references here. So I hope you enjoyed my PowerPoint, and thanks for watching.